Hello, everyone, and welcome to the 2024 AP Free Response Questions Video Key. What an exciting moment for everybody. As we go through this, I've already shown all the work, so I'll explain how to do all the problems. Hopefully this speeds up the video for you a little bit, so it's not as long as it might need to be otherwise. All right, I'm not going to read any of the questions. I'll leave that up to you. But on part A, we are approximating C prime of 5 from a data table that has values of C. This is a typical question that I've seen multiple times. You're approximating C prime 5 using the average rate of change, which is slope between 2 points. So from 3 to 7. So typically, you're just going to find the slope from 3 to 7, whatever these endpoints are. And so basically, to find the slope at a point, you find the slope between 2 points that surround that point. I have seen a problem where it didn't use the endpoints of the interval they gave you. You had to use some interior points. Doesn't really apply on this problem because there are no points between 3 and 7. But let's say 4 and 6 were data points that were also given. Then you would use 4 and 6 instead, because the closer the points are to the point where you're trying to estimate the slope, the more accurate it'll be. Okay, but this is really just an Algebra 1 question, slope between 2 points. On B, using a left Riemann sum, so you can see the work for that right here. And just make sure, show this work right here. You don't need to show what 100 times 3 is, but show the setup. That's usually worth a point. And then right here we have an integral divided by its interval length. So remember, that is average value. So you're finding average value of this function. This function, C of t, is the temperature of the coffee. So you're finding the average temperature of the coffee in degrees Celsius. I would include the units, the rubric usually does. And also always say the time interval on which you found the average value. In this case, we found the average temperature from t equals 0 to t equals 12. All right, and then on C, they give us the rate of change of the temperature of the coffee and ask us to find the temperature of the coffee at t equals 20. Now, this function is only good between 12 and 20. So when you do the integral of the rate, remember, an integral of a rate gives you the amount of change of whatever this is the rate of change of. This is the rate of change of the coffee. So 12 to 20, doing that integral, which you can just math 9 that, gives us the change in temperature of the coffee over that 8-minute time interval. But then our temperature at 12 is 55. So do the change in temperature plus the initial temperature to get the temperature at whatever this endpoint is. And then finally, part D, they give us the second derivative and ask us, this is the second time already this year that we've seen a question like this. Is something changing at a decreasing rate or an increasing rate? Actually, the first question we answered was, is something increasing? We already knew it was increasing. It said, is the thing increasing at an increasing rate or decreasing rate? But really, that's just a second derivative question. So evaluate the value of the second derivative. A lot of times on a question, it'll just be at a single point. And so you just find the value of C prime at a single point. But here it wants to know for this entire interval. Usually for an entire interval, it can't be answered because you would have to test all the infinitely many points between 12 and 20. But we can tell that C double prime is always positive for these t values because this has a t, this part has a t, but that's an exponential, so it's always positive. This is squared, so it's always positive. And then for these t values, we know that this is always positive also. So we can tell that C double prime is positive the entire time on this interval, which I've said here. Therefore, the temperature of the coffee is changing at an increasing rate. Okay? And so really that's just talking about concavity. So when something's concave up, it's getting steeper as you go along the curve, is what that idea is. All right, on number 2, we have a particle with a given velocity. There's one time when the particle is at rest. Find that time. You can just graph it. I would indicate that you are searching for when v of t equals 0, so indicate that knowledge. And then I just said what the time was. And then it wants to know if the particle is moving left or right during that interval from 0 to the time we just found. And you can just look at the graph of v of t. And since v of t is always positive or above the x-axis on this time interval, then the particle is always moving to the right during that time. Okay, for acceleration, show that acceleration is equal to v prime. And then you can just use the math 8 functionality, which we tend to forget because we don't use it as often. But just use math 8 and find the value of the derivative of the velocity, which is acceleration. So just math 8 this. Don't forget this thing here. I've seen a couple people omit that on accident. And then you do need to be able to determine if speed is increasing or decreasing for a particle. Like this will happen on the AP exam for sure. And this is where you find the value of your velocity, which is negative, the value of your acceleration, which is also negative. Anytime velocity and acceleration have the same positive or negativeness, then the speed of the particle is increasing. And you can just summarize that here in this sentence that you can see. I'm not going to read that to you. And then you know that a particle's speed is decreasing if velocity and acceleration have opposite signs. Quick explanation for that is if your velocity, let's say, is 5, so velocity equals 5, and your acceleration is 2, that means, let's say it's meters per second and meters per second squared, that means every second this increases by 2. And so it goes from 5 to 7 to 9, so your speed increases from 5 to 7 to 9. But if we make them both negative instead, now your velocity changes from -5 to -7 to -9, but that means your speed changed from +5 to +7 to +9. So you still get an increase in speed, even though your velocity is actually decreasing here. So a weird distinction there, but in a nutshell, just know that if your acceleration and velocity have the same sign, then the speed of your particle is increasing. All right, on this one, they give us a position at a given time, and they want us to find position at another time. So from velocity, the integral of velocity, we should know is position, or the antiderivative of velocity is position. Now, you can't find the exact position function because of that plus c value. So we do know, though, that the function x of t is the antiderivative of this. So how do you do an integral? Well, you find the antiderivative, plug in the upper bound, and subtract the lower bound plugged in. So you set up this equation. This concept is for sure on the AP exam also. So you got to make sure you understand those. And a lot of times it's not velocity. It'll just be like, it'll say that this is f prime. So you do the integral of f prime, and you know that it's going to be f of 4 minus f of 1. And then one of these pieces of information is always given. This thing you either do by hand, or typically you have a calculator so you can just math 9 it. And so that's what I've shown over here in green. This is the value of the integral because we have the velocity function, so I just math 9 it. X of 1 was given to be -3, so it's minus -3, which is this. And then x of 4 is what we're trying to find. So it just turns into a simple algebra 1 equation. And then total distance traveled, you just need to know that that's the integral of the absolute value of velocity. And for this one, it wants it between 1 and 4, so those are our bounds. All right, number 3, you can look at that solution curve right there. Just ask me questions if you're not sure how that works. Don't forget, you could Google electric field hockey and mess around with that. And that's a good exercise on how something follows the path of a slope field. It's not, remember, electric fields and slope fields aren't exactly the same, but they behave very similarly. All right, on this, on part B, we have to find where there's a critical point and then say if it's a max, min, or neither. So you get a critical point when the derivative is 0. This is our derivative. So it does tell us that h has to be bigger than 1. And what that is telling us is that this part is always positive, so it'll never be 0. So we're only looking at this part to find when cosine is t over 2 is 0. And so cosine of t over 2 equals 0 at pi, because that makes this pi over 2. Algebraically, I didn't show this on here, but if you aren't sure, take the parent function, cosine t, find where it equals 0, so that would be at like t equals pi over 2, 3 pi over 2, 5 pi over 2. And then, of course, you can just stop on the given interval. So 3 pi over 2 is already actually bigger than 5. Well, that's for the parent function. But then we had to set our angle equal to these things. So we actually say, all right, we need t over 2 to equal this, and then you can solve by multiplying by 2 everywhere, which gives us pi, 3 pi, and 5 pi. And then 3 pi is bigger than 5. So ignore what I said about 3 pi over 2. It matters what t value we find. So that's how you can do that from an algebraic standpoint. This one was maybe probably easy enough to figure out logically. And then I think the rubric, if you look, shows the second derivative test on this, which you can use. I used the first derivative test, though, which is a sign chart. Do familiarize yourself with the second derivative test, though, because there are problems that you can be forced to use it the way the question is written. But here I just showed that h prime is positive before pi and negative after pi. And so, again, don't use this as your justification. And then you can read my sentence here, how I summarize this. You don't need to write it in inequality notation. You can just say h prime of t is greater before pi, is greater than 0 before pi, and h prime is less than 0 after pi. But really, it's not after pi the whole time. It's pi until 5. So it's probably best to use this notation so you know where the cutoff is. And then use separation of variables. So separation of variables, make sure you'll see this on the 2023 questions if you haven't already. And it happens a lot where separation of variables will occur a lot when there's only a one variable. So like we'll only see an h, this won't even be here. So make sure you understand how to do that. But basically it's the same thing. You would divide by h minus 1. This stuff just wouldn't be here. I guess the 1/2 would be there. This wouldn't be here, and you just do the integral of 1/2 dt. So there's no variable over here, so the antiderivative would just be 1/2 t. But you'll see that in the 2023 questions. But for this problem, we do have a t anyways. It's right here. So you can separate the variables, find your antiderivatives, put your plus c right then, find your c immediately by plugging in these points. So find c, put your c back in, and then you do some algebra from here, from green to black to pink to get your final answer. You don't need to do the simplification where natural log of 3 comes down as a coefficient, but you can. And then make sure you choose the correct case, positive or negative, that makes this condition true. So when I plug in 0 for t, I got to know is it 1 plus 3 or 1 minus 3. It gets me 4, because plugging in 0 for t will get me 1 right there. So make sure you take a look at that. All right, on 4a, we are finding the value of g of negative 6. G of negative 6 is the integral from 0 to negative 6. So it's this area, but going this direction. So we're going from right to left. We know the area is 12. So since it's above the x-axis, but we're going that way, our area will be negative 12. And then g of 4 is the integral from 0 to 4. So you can just find the area of that triangle. Make sure you show the calculation here. That's worth a point. So don't just write the integral equals 4. Show the calculation. And then same with g of 6. G of 6, I took this area, so I showed it a little different than the rubric. I took this area, which I already knew from the previous answer of 4, and then I subtracted this area, which I showed right there. Because we're just doing integrals of f to find values of g. All right, so then we got to find when g has a critical point. To find when anything has a critical point, you find when its derivative, g prime, is equal to 0. But since g is the integral of f, g prime is equal to f itself. So indicate that, and indicate that you're finding when it equals 0, and then you just can find that from the graph at x equals 4. And then finally, we have a new function h, where h is now equal to the integral of f prime, and then we got to find some values of h. So h of 6, so this is the same idea that we talked about on number 2, where h of 6 is equal to the integral from negative 6 to 6 of f prime. But the integral of f prime is f. So the antiderivative of f prime is f. So here's the antiderivative of our integral with the upper bound plugged in minus the lower bound plugged in. And then you can get f of 6 and f of negative 6 just from the graph, because this is the graph of f. And so that's what I've shown here. H prime of 6, well, if h is the integral of f, then h prime is f prime. So h prime of 6 is f prime of 6. F prime is the slope of this line at 6, which you can just count, and it's negative 1/2. And then h double prime is the same as f double prime. And since this is a line, this is a linear part of f. That means its derivative is a horizontal line at -1/2, because we found that answer here. And therefore, the derivative of that is just 0, because it's a horizontal line. And that's where those answers came from. All right, on number 5, they give us the derivative of something and ask us to do a tangent line approximation. So we're going to find the line tangent to this curve at this point, 2, 4. So I found the slope right here, and then I did point slope. Then we're going to use this line to estimate the value of this curve at x equals 3. So remember, with tangent line approximations, what we're really doing, you have a curve somewhere, we find a point tangent to the curve, or a line tangent to a point of the curve somewhere, and then we're saying, all right, the blue and the orange line curves are basically the same as long as we don't move too far from this point. And so we can find values on the orange line to estimate values on the blue curve instead. So that's what we're doing here. So instead of plugging 3 in for x right here and solving for y, we're saying that this curve and this curve are the same. So we just plug in 3 into this line to estimate that value. So that's how tangent line approximations work. On B, there's 2 ways to do this one. Is the horizontal line y equals 1 tangent to the curve? The way I did it is I said, all right, if y equals 1 is tangent, then the slope must equal 0. So I found where the x value where the slope is 0, which is 0. So now I know the point 0, 1 must lie on the curve for it to be true. So you plug in 0, 1 and you get 5 equals 48, which of course is not true, which means the place that we found the slope to be 0 doesn't exist on the curve. And so there is no slope of 0 that exists on this curve. The other way you can do it, and you can look at the rubric for this, you can plug 1 into this for y and find your x value. So find the actual point on this curve, plug your point that you found into the derivative and see if you get a slope of 0, and you won't. So you can find the actual point when y equals 1 and then test the slope. Or I found when the slope should be 0 and tested the point. So either way. Similar thing going on C. This is a point on the curve. Is the tangent line vertical at that point? You just show that the slope is not undefined at this point. So plug this in to your derivative and show that it is not 0 on the bottom and therefore not undefined. All right, and then on part D, this is related rates for the first time in a while probably. So now x and y are changing as t changes, which is kind of what this first sentence is setting up for us. They give us the rate of change of the y coordinate, and it's decreasing at a rate of 2 units per second, which means dy dt is -2. So you find the derivative of this. So remember, that's 3y squared dy dt. I just kept the 2 out here and then did product rule, but you can treat it as 2x if you want. It's the same thing. But in any case, the derivative of x is dx dt times y plus the derivative of y dy dt times x. And then I just plugged in known values, 4 and 2 for x and y, and -2 for dy dt, and solved for dx dt. All right, and then on 6, so we just have to find the area of R. So remember, area is just integral of top minus bottom. Or if we were going this way, between the curves and the y-axis, you would do right curve minus left curve. So integral of top minus bottom is just that right there. Make sure when you're showing integrals, you put dx or dt or whatever the appropriate variable of integration is. Now we're going to do weird cross-sections. So our cross-section is a rectangle with height equal to half its base length. So in general, what you're doing is you have a rectangle whose one side is x and the other side is 1/2 x. And so the area of this is just simply 1/2 x squared. So what's going on in our problem, though, is we have, sorry, let me erase some of this here. We have, our rectangle length is just extending from here down to there. And so that length is g of x. So instead of x over here, we have g of x as our length, which means this other side is 1/2 g of x. And so our area is 1/2 g of x squared. Like that. And so I just did the integral of 1/2 g of x squared, and then I evaluated the integral, as you can see, make sure your bounds are 2 to 5. I just distributed and then found the antiderivative of everything. I showed it a little differently than the key. You can leave your answer like this, though, as long as this expression is equal to the final answer, then you're good. All right, now let me bring back that picture that I had drawn to save some time here. Hopefully it saves some time. There it is. All right, so this is volume now. So we're revolving the region S around the line y equals 20. So it's going to look roughly like what I've drawn here in orange. And so our cross section, see, all of this is like hollow space right here. The only solid, sorry, including this also. The only solid is the shaded region here and here, and as it like comes out of the screen and into the screen as it gets revolved. So we're going to do pi big R squared minus pi little r squared. Big R is always the curve that's farther away from the axis of revolution to the axis of revolution. Since we're revolving this, or since our region stops on the x-axis, then the big R goes all the way from 20 down to the x-axis. And so it's kind of weird on this one because there's not actually two curves. I mean, there is. The other curve, though, is just y equals 0. So if you want to, you can think of big R as being 20 minus 0, but that's just 20. So big R is 20. And then little r goes from the axis of revolution down to the closer curve, which is g of x. And so the length of this green line is 20 minus this distance, which is g of x. So little r is 20 minus g of x. And so then you do the integral of pi big R squared minus little r squared. Well, it's pi times both of those, but I factored out the pi. And you go from 2 to 5, give it some thickness, multiply by the thickness to give it volume. And that's it.